Welcome back to our cosmic journey through the Milky Way. In this third installment, we're diving into 10 more fascinating facts about our galaxy. Let's get started. Prepare yourselves, fellow explorers of the vast unknown, as we once again cast our gaze towards the luminous band that stretches across our night sky, our home, the Milky Way. It's a place of unimaginable scale, a swirling city of stars, gas, and dust, holding secrets that we are only just beginning to unravel. Each discovery, each new piece of information adds another brushstroke to the grand portrait of our galactic abode, revealing its intricate beauty and its often violent, always dynamic nature. Today we continue our odyssey, peeling back more layers of cosmic mystery. We've journeyed far in our previous explorations, but the Milky Way, in its sheer immensity, always has more wonders to offer, more phenomena to boggle the mind and ignite the imagination. Think of the billions of stars, each a potential sun to other worlds, the vast clouds of interstellar gas where new stars are born, and the enigmatic dark matter that, while unseen, shapes the very structure of our galaxy. It's a cosmic dance on an epic scale, and we are privileged to have a front row seat, and even more so, to be a part of it. So fasten your seatbelts for another voyage into the heart of cosmic understanding. We'll venture from the chaotic flurry of stars near the galactic center to the lonely wanderers flung into intergalactic space. We'll contemplate the conditions for life, the ancient relics of galactic formation, and the very future of our ever-changing stellar metropolis. The universe beckons, and its story, written in starlight and gravity, is waiting to be read. Let the next chapter of our exploration commence, as we delve deeper into the marvels of the Milky Way. Imagine, if you will, stars not content to merely orbit within the gentle gravitational embrace of our galaxy. Some stars, through dramatic cosmic encounters, are given an extraordinary kick, a burst of speed so immense they achieve escape velocity. These are the rogue stars, galactic fugitives, hurtling out of the Milky Way, destined for the lonely expanse of intergalactic space. Perhaps they were part of a binary system where one star exploded as a supernova, violently flinging its companion outwards. Or maybe they ventured too close to the supermassive black hole at our galaxy's core, Sagittarius A*, and were slingshotted away by its colossal gravity, like a pebble from a cosmic catapult. These stellar exiles travel at hundreds, sometimes thousands of kilometers per second, a testament to the powerful forces at play within our galactic home. Their journey is a one-way trip into the cosmic wilderness, leaving behind the familiar stellar neighborhoods of the Milky Way. Studying these high-velocity stars can tell us much about the chaotic dynamics near the galactic center and the extreme events that shape the lives of stars. They are like cosmic breadcrumbs, leading us to understand the more violent and energetic processes that, though rare, are an integral part of the galaxy's ongoing story, a story of constant motion and transformation. We often think of our sun as a stationary anchor around which the planets dutifully orbit. But the sun itself is on a much grander journey, a colossal orbit around the center of the Milky Way galaxy. Our entire solar system, Earth included, is sweeping through space at a breathtaking speed of about 828,000 kilometers per hour, or 230 kilometers per second. Even at this incredible velocity, it takes our solar system approximately 225 to 250 million Earth years to complete just one lap around the galactic core. This vast span of time is known as a galactic year or a cosmic year, a timescale that dwarfs human history. Consider this. Since the Sun and Earth formed, we've completed this galactic circuit only about 18 to 20 times. Dinosaurs roamed the Earth during a previous galactic noon, and the continents were arranged very differently. During each orbit, our solar system traverses different regions of the galaxy, passing through denser spiral arms, where star formation is rampant and supernova threats are higher, and then into sparser inter-arm regions. This epic journey through varied cosmic landscapes subtly influences our environment, reminding us that we are not isolated, but part of a vast, interconnected and ever-moving cosmic ecosystem. Just as planets have a habitable zone around their star where liquid water can exist, scientists theorize that galaxies, too, may have a galactic habitable zone. This is a region within the Milky Way considered more suitable for the emergence and sustenance of complex life. Venture too close to the galactic center, and the environment becomes perilous. The star density is incredibly high, increasing the likelihood of gravitational disruptions and exposure to intense radiation from supernovae or the central supermassive black hole. It's a cosmic inner city, bustling but dangerous for fragile life. Conversely, if you travel too far out, towards the galactic suburbs and beyond, the conditions also become less favorable. The abundance of heavy elements forged in the hearts of stars, and essential for forming rocky planets and indeed life as we know it, diminishes in these outer regions. Star formation is also less vigorous. So there appears to be a cosmic Goldilocks zone within the Milky Way, not too close to the chaotic core, not too far out in the metal-poor periphery. Our own solar system resides comfortably within this proposed zone, a fortunate cosmic address that may have played a crucial role in life's development on Earth. Chapter 4: Ancient Stellar Cities, the Globular Clusters. Orbiting the main disk and central bulge of our Milky Way like ancient satellites are more than 150, and perhaps as many as 200 spectacular objects known as globular clusters. These are not just loose associations of stars, they are tightly bound, spherical collections, each containing hundreds of thousands, sometimes even millions of stars, packed into a relatively small volume. Imagine a sphere perhaps a few dozen to a few hundred light-years across, teeming with ancient suns. The stars within these clusters are among the oldest in the galaxy, some nearly as old as the universe itself, born in the Milky Way's infancy. These stellar cities are relics from a bygone era, providing invaluable clues about the early conditions and formation of our galaxy. Because the stars within a single globular cluster all formed at roughly the same time and from the same cloud of gas and dust, they offer a unique laboratory for studying stellar evolution. Their dense environments also lead to fascinating dynamical interactions, like stars colliding or capturing each other. Observing these ancient glittering baubles, scattered in the halo of our galaxy, is like looking back into the deep past, witnessing the Milky Way's earliest building blocks, still shining brightly after billions of years. Chapter 5: The Milky Way's Barred Heart. For a long time we pictured the Milky Way as a classic spiral galaxy, with graceful arms swirling out directly from a spherical central hub. However, more recent observations, particularly in infrared light which can penetrate the obscuring dust, have revealed a different, more complex structure. Our Milky Way is in fact a barred spiral galaxy. This means it possesses a large central bar-shaped structure composed of billions of stars, gas, and dust, stretching tens of thousands of light-years across its core. The spiral arms we observe appear to emanate from the ends of this stellar bar, rather than from the very center itself. This central bar is not just a static feature, it's a dynamic engine that plays a significant role in the galaxy's evolution. It's thought to channel gas and dust from the spiral arms inward towards the galactic center, potentially fueling star formation in the core and feeding the supermassive black hole Sagittarius A*. Understanding the bar's formation and influence helps us piece together the puzzle of how our galaxy developed its current shape and how it continues to change over cosmic timescales. It's a reminder that even the grandest structures in the universe have intricate details that reveal deeper workings. Chapter 6: The Unyielding Grip of the Galactic Center. At the very heart of the Milky Way, shrouded in gas and dust, lurks Sagittarius A*, pronounced Sagittarius A*, a supermassive black hole with a mass more than 4 million times that of our Sun. Its gravitational influence is profound, dominating the dynamics of the stars in its vicinity. You can't escape this central gravity easily if you're a star orbiting nearby. The pull is so immense that stars caught in its sway are whipped around in tight, incredibly fast orbits. Some of these stars have been observed moving at astonishing speeds, thousands of kilometers per second, as they dance precariously close to this cosmic behemoth. These stellar speed demons provide some of the most compelling evidence for the existence and mass of Sagittarius A*. Their rapid Keplerian orbits trace out the gravitational field of an object that can only be a supermassive black hole. Observing these S-stars, as they're known, is like watching a cosmic ballet performed on the edge of an abyss. Their frantic pace highlights the extreme environment at our galaxy's core, a place where gravity reigns supreme and shapes the destiny of everything that ventures too close, a powerful anchor around which our entire galaxy revolves. Chapter 7. A Galaxy in Flux, the Ever-Changing Milky Way. The Milky Way, as majestic and enduring as it appears, is not a static, unchanging entity. It is a dynamic system, constantly evolving, slowly but surely changing its shape and structure over billions of years. The spiral arms we see today are not rigid structures but rather density waves, regions where gas and dust are compressed, triggering star formation. These arms shift and reform over eons. The central bar itself may grow or shrink, and its influence on the galactic disk can vary. Our galaxy is a living, breathing cosmic entity, albeit on timescales that defy human comprehension. Furthermore, the Milky Way is an active participant in the cosmic dance of galactic interactions. It's currently in the process of consuming smaller satellite galaxies like the Sagittarius dwarf spheroidal galaxy, whose stars are being tidally stripped and incorporated into our own. In the distant future, about 4.5 billion years from now, the Milky Way is destined for a colossal collision and merger with our nearest large galactic neighbor, the Andromeda Galaxy. This cosmic event will dramatically reshape both galaxies, eventually forming a new, larger elliptical galaxy. Our galaxy is a work in progress, a testament to the universe's perpetual state of transformation. Chapter 8. The Undead Stars, Cosmic Zombies. In the stellar necropolis of our galaxy, there exist entities that defy conventional expectations of stellar death, the so-called zombie stars. These are typically white dwarfs, the dense remnants of sun-like stars that experience a peculiar type of supernova. In certain binary systems, a white dwarf can accrete matter from its companion star. If it gathers enough material to reach a critical mass, it can undergo a runaway thermonuclear explosion, a type Ia supernova. Usually, this is thought to completely obliterate the white dwarf. However, some evidence suggests that not all these explosions are terminal. In some instances, the supernova might be incomplete, or the white dwarf might somehow survive the cataclysmic blast, perhaps being partially consumed but not entirely destroyed. These zombie stars would then continue to exist, scarred and transformed but still shining, having cheated stellar death, at least for a while. The mechanisms behind such survivals are still being researched, pushing the boundaries of our understanding of supernova physics. They represent a fascinating, almost macabre chapter in the life cycle of stars, where even after a seemingly fatal explosion, some stellar embers can continue to glow in the cosmic darkness. Chapter 9. Rebels of the Revolution, Backward Orbiting Stars. The vast majority of stars in the Milky Way's disk, including our Sun, orbit the galactic center in a generally uniform, prograde direction, much like planets orbiting a star. However, astronomers have discovered a fascinating subset of stars that defy this cosmic conformity, stars that orbit the Milky Way backward, in a retrograde direction. These stellar rebels are not native-born citizens of our galaxy, they are immigrants, cosmic travelers captured from elsewhere. Their contrary motion is a telltale sign of their external origin. These backward-orbiting stars are thought to be remnants of smaller dwarf galaxies or globular clusters that were gravitationally ensnared and disrupted by the Milky Way over cosmic history. As these smaller systems were torn apart by our galaxy's tidal forces, their constituent stars were strewn throughout the Milky Way's halo and sometimes even its disk, retaining the orbital characteristics of their parent system. Studying these retrograde stars, their chemical compositions and their trajectories provides invaluable archaeological evidence of the Milky Way's past mergers and its history of galactic cannibalism, revealing how our galaxy grew to its current majestic size. Chapter 10. Charting the Unseen, Less than 1% Mapped. Despite our most advanced telescopes and ambitious space missions, the sheer scale of the Milky Way means that we have, quite literally, only scratched the surface in our attempts to map it. It's a humbling realization. We reside within this vast stellar metropolis, yet we've charted less than 1% of its stars with high precision. Imagine trying to map an entire sprawling city while being confined to a single neighborhood with your view often obscured by buildings and smog. For us, the smog is interstellar dust, vast clouds that block visible light from distant parts of the galaxy, especially towards the galactic center and on the far side. Missions like the European Space Agency's Gaia spacecraft are revolutionizing our understanding by meticulously charting the positions, distances, and motions of over 1 billion stars. This is an extraordinary feat, creating the most detailed three-dimensional map of our galactic neighborhood ever conceived. yet even a billion stars represent just a tiny fraction of the estimated 100 to 400 billion stars that call the Milky Way home. The vast majority remain unplotted points of light, their stories untold, their exact locations unknown. Our cosmic cartography is an ongoing endeavor, a testament to our enduring quest to understand our place in this immense and largely unexplored stellar island we call home. Outro: the ever-expanding horizon. And so, our brief excursion through another 10 wonders of the Milky Way comes to a close. From stars flung into the void, to the ancient globular clusters that whisper tales of galactic dawn, from the unyielding gravity of its core to the surprising notion of zombie stars, our galaxy continues to astound and inspire. Each fact we've uncovered is like a single star in its immense tapestry, contributing to a picture of breathtaking complexity and beauty. Yet as we've seen, even with all we've learned, the vast majority of our galaxy remains a profound mystery, an uncharted territory beckoning future explorers. The quest for knowledge is a journey without a final destination, especially when the subject is the cosmos itself. The Milky Way, with its hundreds of billions of stars and countless secrets yet to be revealed, reminds us that there is always more to discover, more to understand, and more to marvel at. It's a humbling perspective, to realize our small place in such a grand scheme, but also an empowering one, as it fuels our innate curiosity and our drive to reach for the stars, both literally and metaphorically. The universe is generous with its wonders if only we take the time to look. Thanks for joining us on this stellar adventure. Don't forget to like, subscribe, and hit the bell icon for more cosmic content. Until next time, keep looking up. May your curiosity continue to guide you through the vast and wondrous expanses of space and time, and may you always find awe in the intricate workings of our universe.